Hello everyone, we are Group 12 and my name is Nimish Parnikar. My enrollment number is BT18CSC099. Today we are going to demonstrate our project called Mask Alexa, which is an voice assistant which helps us to detect masks using voice commands. First, we initiate Alexa using Alexa command, and then when Alexa prompts us to be ready and say check for mask, we get ready with our mask and say
Hello, I am listening. When you are ready, please say check for mask.
check for mask.
Okay, checking for the mask. Mask is detected. Verification successful.
It has now recognized the mask.
Going back to sleep mode.
It automatically closes.
Thank you and shut down.
Alexa off to sleep.
We can press the mic button and then it again starts listening to our commands.
Hello everyone, my name is Pulkit Batra and my roll number is BT18CSE052. Now me and Gopal will explain about the GUI of our code. Now we have built a GUI using Electron, which is used to build a desktop app. Electron is a framework for creating native applications with web technologies like JavaScript, HTML and CSS. So now let's head over to the exe to see how it looks. So as you can see, our app is up and running. So now let's head over to the code to see how it works. So as you can see, first we have the JSON file, which has the basic information about all the details of the app. So the name of our app is Alexa and the version of Electron is 10.1.5. We have integrated our main.js file here. The scripts that we have for Electron are listed here, and as we have built our backend using Python, so these are the Python dependencies which are installed. So now let's head over to the index.html file. So here you can see this is the heading to create the masked Alexa effect here. Next, this is the mic image to create this image which is here. So as you can see, we have given three states to the color which is hovering around it. The first color is red to indicate that the mic is off. The second color is gray to indicate that currently mic is being hovered on. And the third color is green, of which we have seen in the working video, to indicate that the mic is on. So next is the exit button to exit from this app. Also, we had to integrate JS file and CSS file to basically give all the effects. So now let's head over to these files and see how they work. So this is the CSS file. As you can see, it has all the basic commands of CSS to give the coloring and effects to the tags on the screen. Basically the h1 tag, the body tag and all of that. The main thing to look out here is the pulsating effect that we have given, which is using this pulsating WebKit, where our hovering goes from 0 border to 10 border to 0 border in an interval of 2 seconds. As you can see, every 2 seconds the color changes from 0% to 50%, then to 0%, and the border changes from 10px to 0px, and therefore we can see this effect. So this was all about the CSS part and the HTML part. Now let's head over to Gopal, whose roll number is BT18CSE56.
Now that we have seen what is Electron and the basic GUI, let's dive deep into it. So first we'll open Alexa and we'll place it on this side, and then we'll open the code and see. So as you can see, Pulkit has already explained index.html and index.css. So now we'll be understanding the JavaScript behind this. So first of all, whenever we want to click this button and open Alexa, we need to use JavaScript. So how Electron works is, it uses a main.js that is opened at first. What this main.js does is, first of all, it creates an app, and when that app is ready, it creates a new window. Inside that window, it sets a custom menu that we have made, where we have the instructions and credits. So this is all made by us. Here we have used this template for making the menu. Next, after the menu is created, then we can look into what is the rest of the JS file. inside this min.js we have one more function which is create window. This is how window is created. This creates a new browser window. As we know that Electron works on web technologies, and it loads this index.html file which is loaded inside this, and then whenever window is closed either from this or from exit, then it just makes the window null so that it can be collected and we can release all of the memory that Electron is using. Now let us see what other things are. Inside index.js, whenever we click this button, that is the mic button, we can see that from index.html, when we see index.html, we can see that where here we have this button and button ID is mic. Now from that button we have inserted an listener inside it, and whenever it detects that listener, what it does is it sends an IPC with the string mask into the main.js. Now what happens is this is just a renderer window, and main.js is actual controller of the whole program. So IPC is just inter-process communication. The index.js detects that this button is clicked and it sends a inter-process communication message to the main.js, where main.js receives this message here ipc.on mask. Now it another triggering is happening over here. We can see that once it detects that mask, then it says to call this function spawn.py, spawn underscore py. Inside the spawn underscore py, we simply create a Python shell and we open the py file. What is py file? Py file is this mask.py, which does all of the backend stuff, which is detecting voice, audio, and detecting the mask. So from here that Python is generated, and whenever Python comes out, that is Python is over, then it reloads. We'll see why it reloads. So whenever we click this button, we can see that this halo effect turns green. This is done by index.js, where it turns the into green, and we can see that whenever Alexa goes off, turns off, then it again turns red. This is also done by JavaScript. So this is the whole working of JavaScript and how it uses index HTML and CSS as a front end and connects it to the back end of Python.
My name is K. Banprakash. My roll number is BT18CSC102. So I'll be explaining how the Alexa code is written and what are the functions in it. So here we can observe the line Alexa equal to create Alexa with three input parameters, and this function creates the Alexa object. So let's check the function. So here we can observe the create Alexa function, which takes three input parameters. One is words per minute and then volume and then voice. Words per minute is the words spoken out by Alexa per minute, and the volume can be set between 0 and 1. 1 is the maximum value and 0 is the minimum volume of the Alexa. And voice MF is the index through which we can set the Alexa voice either into a male voice or a female voice. 0 is for male and 1 is for female voice. And after that, here we can observe I equal to SR dot recognizer, which creates an speech recognition object which we use for later in converting text to voice to text. And then after that, here we can observe while block. Here the text to voice function is used in the first, which converts the given string hello I am listening into voice as an output. And let's explore the text to voice function. So in text to voice function, Alexa.says gives the output of the given string in voice format. And after that, voice to text function, which takes five parameters, which is an Alexa object and time limit of listening and phase limit and looping variable, which is a boolean variable either true or false, and recognize the object. So let's check the function. Here this function is used for converting the voice to text, and here we can observe while loop, which has a break statements within it, which are executed when the right conditions are applied. And after that, here we can observe the time limit and phase time limit are set for the listen function through TL and PL variables. And after that, Google recognizes the audio into a text format, means string format, and returns the output. So the looping variable can be used whether to loop or not when an exception occurs. If false is set, then the break statement would execute and we come out of the loop, and true is set, then the looping continuously goes on until the exception will not be occurring. And after that, here we can uh, here we can observe check Alexa function is used for getting into this if block, and elif and this function is used for breaking out of the loop. And let's explore check Alexa function. And in check Alexa function, here we can observe that first we check whether the given input string is empty string or not, and then we convert all the words in the string into lowercase in form of a list, and check whether Alexa word is present in it or not. And after that, mm, if we want to explore the end this function, which ends the looping of the code, here we can observe the function. Here also the same thing, we check whether the string is empty or not, then convert it into lowercase of list and check whether these words are present or not. If this word no words list, any of the word in the no words list is present, then we return a false value. Else if shutdown value is present, shutdown word is present in the given input statement, then we would be returning true. And after that, here we can observe once we get into the if block, here we say that when you are ready, please say a check for mask as an input string to text to voice function, which is spoken out by Alexa. And after that, mask verification value is set to true if the mask verification is done successfully, or else by default it has a false value. And here, and another voice to text is used, in which the user will be saying his second command, and if this second statement has anything related with checking of the mask, then it enters into this if block, or else it would be entering into this elif and checks whether anything related to terminating of the program is said by the user. If it is true, then it will break out. Else, if checking mask is true, then it enters into this block, or else if unrelated command is entered, then the looping still continues. Let's assume the user has entered the correct command for checking of the mask. So let's explore the check underscore mask function. Note here we need to observe that check mask and check underscore mask are two different functions. So let's explore check underscore mask function. So here in check underscore mask function, we check whether the given input statement is an empty string or not, and later we convert it into words of lowercase for the processing purpose, and in words list contains the words which need to be present in the statement for correct execution, and no words are the words or list of words which should not be present in the given statement. After this looping process, we return a false if return statement will not be occurring in any of the loops. Else, if everything goes right, then true will be sent out over here. After this, here we can observe a flag variable which has checkmask function, and let's explore the checkmask function in later part of the video. If the flag is true, then mask verification value is set to true, and if mask verification value is set to true, then mask is detected, verification successful is the output text spoken out by Alexa. And after all this looping, when the termination of the code occurs, then we would be printing end in the terminal, and voice and text Alexa to sleep is spoken out by Alexa, and then Alexa is stopped. So let's check the checkmask function. So the checkmask function is used for processing the mask through webcam, whether the person is wearing the mask or not. This is fully explored by Shubham Sagar.
Hello everybody, my name is Shubham Sagar, BT18 CSE 101. I am going to explain about the image processing part in the checkmask function. Following are the libraries which I have used in the code, where CV2, TensorFlow, VideoStream, Imputils, NumPy, and image processing. Let's jump to the checkmask function which we have declared. The following are the four parameters which we have used, and where two are for counters and the two are flags. These are two files we have used for the model purposes for detection of faces, and with the model of that faces you passed into the facenet parameter. And for a mask detection, mask.detector.model is used, and we have passed into mask detect. And now we are starting the taking of the video streams from it, and we are running a loop over the all the frames. Okay, and we have taken a particular frame and resized it, and we are calling the detect and predict mask function, and we have passed the frame, face net model, and mask net model. And let's jump to the detect and predict mask function. We have to reshape the frame, and we have converted into a blob and passed to the face net, and we have taken the we have got the detections. Okay, now we are if detections we have run over loop for multiple detections. Okay, because multiple faces may be detected on a particular frame, so for that purpose loop is introduced. Then we have taken the confidence from that particular detection. If confidence is greater than 0.5, we have taken in consider that face is detected. Okay, now face is detected, so we have to kind of create a box over it. So we have created box, and xy coordinates, starting and ending coordinates, we have taken from it, from that box, and following calculations has been done. Okay, now from a particular frame, a face part is there, only face part is considered from that particular frame, and we have converted the face color from the bgr to rgb, and we have resized and converted into an array and pre-processed it. So suppose if multiple faces are there, so it is appended to a faces dot parameter, and the locations has been appended to this, because finally we have returning locations and predictions. So for that purpose, locations should be there of all the faces. If length of faces, that is multiple faces are there, or face is detected, then face is should converted into an array, and we have passed it to the mask net function, where we have checking for the mask is there or not, which returns a tuple which we have passed to return. Okay, as location and predictions are there, we have to unbox this location predicts, so we have unboxed it, and the starting and ending coordinates from the box is taken, and prediction returns mask and without mask tuple. Okay, if mask is greater than without mask, that means mask is detected. Okay, then we have count the mask. We have introduced count marks because if a particular frame takes millisecond for taking a particular frame. Okay, in that particular frame we can't detect if fast is there or not, so we have to loop over multiple passes. So count mass is greater than 10, that is in 10 frames mass is detected, so we have returned this flag value true. If mass is not detected, we have to count the number of marks, not mass is plus 1, and we have run over a loop till until we get the number of mass greater than 50. As it the number of mass is greater than 50, we break from this function. Okay, and this particular code is used for creating a rectangle and text on the particular face, so that mask is detected on it, where the text is mask or not no mask. Okay, and this we have displayed by using the cv2.im show, and the key is introduced for breaking of the image capture. Okay, as q is pressed when the image capturing is done, so it breaks from the image capturing and destroys all the windows, and we have finally written the flag value. Okay, that's it. And we have taken this reference, this checkmarks function from this following GitHub. Thank you.